Hey everyone, this is a fun weekend project that I did, and it has no real purpose, but I wanted to share it because I thought it would be pretty cool. So I'll just get right into it. Disclaimer, this is just an exploratory project. These ideas are kind of dumb, and these ideas have been done before by people at Spotify and Lyft and Airbnb and other companies. So there's a famous quote from Steve Jobs about the iPhone that the phones before the iPhone had physical keyboards. So if they wanted to update the phone with a new idea, they would have to ship a new phone, which takes like over a year. So Steve Jobs' real innovation with the iPhone was that you can ship a new UI to the users without having to update your physical hardware. So you can think of that kind of with physical device development as well, but you can also think of it in software development. So being able to easily change the UI over time. This is kind of the holy grail of software development, which is that theoretically we want to write once, ship everywhere, and ship at any time that we want. The reality of this is nearly impossible, that you really have to ship your app or your website over a long period of time and roll out updates progressively. But perhaps we could work backwards to cool things that we could do even if we, can't fully roll out the app immediately. So Mark Zuckerberg, of course, famously tried to do this with HTML5. So this goes back to the write once, ship everywhere, ship anytime. So, Facebook really wanted to immediately update all of their apps across Android, iOS, and the web just by pressing a single button. And we all know that once iPhone apps and Android apps natively became promising, they stopped doing that. So it kind of gets us back to this idea of, how can you change controls without having to ship very often? So that's kind of the real problem, is that we have an app development lifecycle, which takes about 7 days. That goes through an app review, which takes 1 to 2 days. We have some app distribution with progressive rollouts, which take 7 days. And then we have some app usage, which for backwards compatibility could be over 3 months to a year to multiple years. So often when we ship our app, we need to have dynamic behavior. So there might be situations that we didn't foresee, like adding a new button or removing some UI that we might want to change in the future. So the way that we get around this currently is mainly through 4 things, and there might be another one you can imagine that I might have missed. But one is feature flags, so we can, change app content dynamically with feature flags. There's also a content management system like CMS, where you can just deploy some content and then your app automatically updates. You could have server-side fonts, color files, so these could change your application behavior without having to update the app over time. There's also just having a server API, right? So either this gives you new data in the app, or you want to have some layout driven by a server and get your app to update automatically. So this is called just dynamic behavior. It's things that we want to change once our app is in the App Store, and we want to be able to do that. So getting into the demo. So I'll show the architecture after this, but basic idea, I have some way to control SwiftUI from a website, and I have a server, and I have an app on the right listening to my server. And every time I make a change to this file, I can then reflect new UI on the right. So I change this, and then it removed support your health. I change this, and then I remove another row, and then I remove this and change it back to what it was. So the app itself is not recompiling at all. Basically, it's just listening to an endpoint and updating natively SwiftUI with a representation of the SwiftUI on the left. So to me, this kind of seems like magic, but under the hood, it's quite complicated, which I think is why we never really would use a system like this in production. But I think it's just a cool exploration, so I wanted to point out how it would work. Other things you can do here, you could have no data at all. Obviously, you could remove an entire section. So anytime you change the SwiftUI on the left, on the right, you'll immediately see the updates reflected easily. So that's kind of the project itself is basically just easily updating the UI without having to recompile like a native Swift application. And the architecture for this, so I am using Swift syntax, which is an open source library. It's basically just a way to parse Swift code using a Swift command and then be able to recognize like the syntax tree of that code. Now, I do have a server and I do have the iOS app obviously on the right. So we have the client iOS app on the right. I have a TypeScript server running in the background. The TypeScript server has a Swift command, which is basically just calling a Swift syntax program, which is reading the UI that I wrote in the web browser. The Swift syntax code, I'm putting it into a JSON representation. That JSON representation gets kind of computed into a TypeScript model, and then that model gets saved to a database. So in the database, after I compile, I basically have a reference to like all of the SwiftUI code and the hierarchy for that code, excluding any like variables. And I haven't added property fonts, colors, things like that. I haven't supported that yet. So that's the post flow, is just the submission of the code to the database. The get flow, so this iOS app on the right is just polling the API like every few seconds, and that hits the TypeScript server, which then hits the Postgres database to check for changes. That then converts the Postgres data back to a JSON representation. That JSON representation then gets served to my client. The client then takes that JSON and renders it back into native SwiftUI, and that's what you have on the right. So as you can see, like in production, you really never want to do this. Like, it's way too complicated, obviously. On the one hand, you have kind of a Swift syntax script where that script has to understand every aspect of your program, and obviously it doesn't work with like dynamic, state changes and things like this. It's really just reading the syntax and trying to represent that in JSON. And yeah, that's basically how it works. Again, there's no real purpose to it. It's just kind of exploring ideas around, how could you use like a web browser and store data in a database and get it back in your app. So yeah, comment any of your thoughts, and perhaps there's some more exploration here that I could do in the future, but that's what I've done for now. So thanks.